Hi, in this lesson, we want to illustrate how to use Excel binomial distribution function to compute binomial probabilities. Let's start by opening up the function into the main window. The function name is binom.dist. Let's open it up. It takes four parameters. The first one is the number of successes. The second is the number of trials or sample size. Then we have the probability of success, which must be entered as a decimal value between 0 and 1. So if we are given a probability of success 12.5%, then we will enter it as 0.125. Then we have a cumulative value, which must be entered as false or true. If the cumulative value is set to false, the binomial distribution function will compute probability of the type probability x equal 0, 1, 2, 3, and so forth up to the sample size. So if we want to compute a probability, let's say probability that x equal 1, then we will set the cumulative flag to false. All right. If the flag is set to true, then the probability will cumulate from 0 all the way to the value that we entered. For example, if we enter the number of successes to, if we set the number of successes to 1 and we set the cumulative to true, then it will compute probability that x equals 0 plus x equals 1. In other words, it will do cumulative probabilities from 0 up to the number of successes we specified. All right, let's step through a problem. That's the best way to understand how to use the binom.dist function. We have this problem. A firm produces light bulb estimated from prior data that 10% of the bulbs are defective. So this is the probability of success from prior data. Now, if we randomly select 100 light bulbs, what is the probability that one is defective? So here we want to compute the probability that exactly one is defective. So the way we will compute, use the Excel binom.dist function to solve question number 1 is that here number of successes will be 1. We want the probability that 1 is defective. The number of trials is the sample size, which is 100. The probability of success is given by 10%, so we will enter 10%. Then for the cumulative value, we will set it to false because we want to calculate exactly the probability that x equal 1. Now, the return value will be 0.000295127. This is the answer. Okay, so for the second one, if we randomly select 100 light bulb, what is the probability that at most 10 are defective? At most 10 are defective means up to 10 are defective, which means we will calculate probability of x less or equal to 10, which will be probability of x equals 0 plus x equal 1 plus x equal 2 in this fashion all the way to 10, which means that we have to cumulate the probabilities from 0 up to 10. In this case, we will have to set the flag to true. And here, at most 10, so number of successes will be 10. The number of trials is still 100. The probability of success is 0.1, but the flag must be set to true. Why? Because we want to calculate probability that at most 10, which means up to 10 are defective. So the answer is 0.583. Third, the question is, if we randomly select 100 light bulb, what is the probability that more than 10 are defective? More than 10 are defective means 11, 12, and so forth, all the way to 100 are defective. So we can use the complementary probability rules to say that if we want to calculate probability that x is greater than 10, which is what it means, more than 10, probability that x is greater than 10, that will be 1 minus probability of x less or equal to 10. In other words, to find that answer, we will then subtract from 1 the probability cumulated up to 10, which we just computed to be 0.583. So here the answer will be 1 minus 0.583. All right. Fourth, if we randomly select 100 light bulb, what is the probability that less than 10 are defective? Less than 10 will mean less or equal to 9. So in which case, here we change the number of successes to 9, and we will get the answer 04129. And finally, 5, if we randomly select 100 light bulb, what is the probability that 10 or more are defective? 10 or more are defective. This is probability that x is greater or equal to 10. Greater or equal to 10. So what we need to do, we will calculate up to 9 cumulated and then subtract this from 1 to get question 5.